Hello and welcome to our lesson on inscribed angles. We're working with circles and we're going to continue that by talking about a new term, terms actually, and that it would be inscribed angles. It's a very nice, neat formula for it, but we need to know what an inscribed angle is. So inscribed, it's exactly what it sounds like. It's inside of the circle. And we are going to draw a couple of points. Let's first draw our center. Let's call that C. We're going to draw 3 points, really, that are on the circle. Doesn't matter where they are exactly. And we're going to draw a couple chords. Now, if you notice, when we draw these chords, they actually create an angle. And that angle here is going to be our inscribed angle. So if you were to give a rough definition of an inscribed angle, you could probably say that it is an angle whose vertex is on the circle and whose sides are chords. So we built it based off exactly what we just said. So an inscribed angle. An inscribed angle is an angle whose vertex, in this particular case, let's call this A. Let's call this actually D. Let's make the angle A. And then put a B here because we already have C for the center. Whose vertex, in this case it is A, is on the circle. And whose sides are chords. And we can clearly see that AD and AB are chords in it. And if you're wondering, if we drew this through the diameter, yes, this would also be an inscribed angle as well, because as we know, a diameter is a chord. All right, so that's an inscribed angle. I'm gonna highlight that in green. So this is our inscribed angle. Okay, we also have this arc here, this arc measure. This arc measure is going to be very, very useful in this case. Okay, we actually call this the intercepted arc. Intercepted arc, and this is the part of a circle, circumference. So as you can see, it is literally just an arc length or an arc measure. Part of a circle's circumference formed when a line or lines, I'm going to put an S there, cut across it. Okay, so this intercepted arc is this arc length, or arc measure, if you will, dB. Okay, and here's your theorem for it. Anytime we have an inscribed angle, we could use this kind of formula. So it's our inscribed angle theorem, and it's very, very easy. We're going to define it. Inscribed angle theorem. And here's the equation for it. Well, here's a rough definition of it. The measure of an inscribed angle is half of its intercepted arc. Okay, so let's just run a couple through really quickly. What this means is we'll take this, the measure of angle A is always going to be equal to 1/2 of the measure of dB, no matter what that is. So if I put dB here, I'm going to do this in pink, if I put like 100 degrees here, that is for this intercepted arc. That means this would have to be 50 degrees. If I put 80 degrees here, this would have to be 40 degrees, okay? If this was 200 degrees, this would have to be 100 degrees, okay, and so on and so forth. So there we have it. anytime you have, and we could do this in reverse too, because the relationship would be double in the other direction. So if I put, for instance, a 45 here, this would have to be 90. Okay? So it works both ways. Now, we also have some corollaries that go along with this, and this is where it does get more interesting. So here is kind of a break. We have like kind of different things that happen when we have inscribed angles. So we call these the corollaries to inscribed angles. Okay. So this first one, there's like kind of like three different cases. We have, first case, we're going to need to draw a circle. You're going to draw these smaller. And here's the kicker. What happens if I draw a inscribed angle here? Well, we know for sure whatever angle this is, let's call this X, Y, and then A, whatever arc measure this is, so I'm going to XY is in red. Whatever XY is, A will be half of that. So if I put, for instance, let's draw this in blue. This would be the chords that lead to A, and we have vertex A. So if I, for instance, put like 100 here, this would have to be 50. Well, what happens if I actually draw another inscribed angle using the exact same endpoints? So I'm going to put another set of chords using X and Y as endpoints. Let's call that B. Okay. Well, doesn't this angle have the same intercepted arc? So doesn't that mean this would also be hypothetically 50 degrees? Yes, it would. This should also be 50 degrees by definition. Now, these are numerical examples. These were in pink. You didn't have to copy it down. But we should know that if two inscribed angles have the exact same intercepted arc, or congruent intercepted arcs, then their measures will be congruent. Okay? So let's actually write this out. This is the case where two inscribed angles that intercept the same arc, same or congruent arcs, then it's not an if then. This is the case where two inscribed angles that intercept the same or congruent arcs. Okay, so we could clearly see that XY is that same arc here, and we could say, for example, if the measure of XY is equal to 80 degrees, then angle A would be equal to, let's be more specific because there's more points on here, XAY would be equal to 40 degrees, and angle XBY would also be equal to 40 degrees. So that's just, these would have the same measure no matter what. Okay? Case two, and this is the more interesting one. You're going to probably see this more often than you think. Okay? In this particular case, we're going to draw a diameter. So I'm going to put a line right through the middle of this, and then I'm going to draw in one other endpoint. Well, here, I'm going to draw some chords, and I'm going to draw a center O, and here we have an inscribed angle in a semicircle. If you don't believe me, I'll draw the semicircle. Here's your semicircle. It wraps around here. There's your half circle. Okay, let's call this ABC. All right, so this is the case where an inscribed angle is in a semicircle, is always a right angle. You don't believe me? Well, we know that this is 180 degrees. So that means its inscribed angle has to be half of that. Half of that is 90 degrees. And no matter what, if I drew, for instance, another one here to here, it would still follow that same measure because half of 180 is still going to be 90. So here's a quick example of it. Example, if AC is the diameter, then angle ABC is equal to 90 degrees. Okay? AC is clearly the diameter, so we have that intercepted arc of 180 degrees, and then that B will, no matter what, will be equal to 90 degrees. So let's draw that angle in green again, just so we could see it. And then diameter, obviously, right through that middle. All right, last case that we do see is this. I'm going to draw a third case. This one's an interesting one because we're not going to see this that often, but if we do, you should be kind of conscious of it. And it's very much related to what we see in kind of number 2, but in a whole circle sense. We're going to draw a quadrilateral in here. Quadrilateral meaning we draw 4 sides. Okay, that's a terrible quadrilateral. Let's draw it like this. Let's draw it a little bit strange. Okay, kind of looks trapezoidal. That's okay. I'm going to call this A, B, C, and D. Okay, now here's the fun part. Opposite angles here, let's actually just write the theorem, just because it might be easier to explain. The opposite angles in an inscribed meaning it's inside of the shape, inscribed quadrilateral. So this quadrilateral is inside of the circle. Circumscribed would be the circle because it's outside of the quadrilateral. Quadrilateral are supplementary. So if you remember, supplementary means they add up to 180 degrees. And let's explore why really, really quickly. And this kind of got cut off, so let me move this over a little bit. Supplementary. Okay, so let's explore this really, really quickly. We know that a circle should always have 360 degrees around. So if we consider this angle C here, and then its intercepted arc in blue, okay, that means, let's say this would be, if this was like 200 degrees, that means this would be 100 degrees, okay? But if you consider the rest of the circle in red, that would be related to the opposite arc, or the opposite angle. DAB would be the remainder of the circle. So together the blue and the red make 360 degrees, but since these angles on the inside, these inscribed angles are always equal to half of it, it should be equal to 180 degrees. So this would be 80 degrees. And if we did the math, this would be 160 degrees. So if you understand that concept that a whole circle is 360, but then these angles the inscribed angles are always half of it, opposite angles should always equal 180, or so they should always be supplementary, okay? So I'm gonna erase those because numeric values don't always help. It's better if we just do 1 tick, 2 ticks, okay? And here's our example of it. Example, angle A plus angle C will always equal 180 degrees. Angle D plus angle B would follow the same because they're opposite angles in a quadrilateral, okay? I'm gonna highlight this just so we can see it. This one was red, so that's angle A. This one was blue, angle C. All right, so there we have it. If you do have any questions on any of these, please, please ask. Just remember, this is our main formula. Inscribed angles are always equal to 1/2 of its intercepted arc. All right, that's all I have for you today. I'll see you in the next one. Bye.